everybody. So in today's video, we're going to be going through the ideas from task 12.5 in case you either weren't here in class or you just need a little extra help. The first thing we're going to do is review an idea that you may have learned before, which is about something called Pythagorean Theorem. When you were in Math 2, one of the things that you learned about was Pythagorean Theorem. So let's say that we know that this shape is a rectangle. That tells me that all four of these angles are right angles, including the one that's inside the triangle. Now, if we look at this triangle right here, which is formed by the diagonal and the two sides of the rectangle, I can see that that's now a right triangle. So if I want to find the length of the diagonal, which is this guy right here, I'm going to be able to use Pythagorean theorem to do this. As a reminder, the Pythagorean theorem is a squared plus b squared is equal to c squared. And in this formula, the a and the b and the c represent the side lengths, but the most important thing you need to know is that the c is always the hypotenuse. It's always the longest side. So if I was to use these numbers, I would plug them in like this. I would use the 12 as a, so 12 squared, plus the 5 as b, so 5 squared, equals the x, the missing number, has to be my c because that's the hypotenuse. Now, when I simplify this, 12 squared is 144, plus 5 squared is 25, equals x squared. 144 plus 25 is 169. And the square root of 169, if you remember from doing this before, we always use a square root to undo that squared. The square root of 169 would be 13. So the length of that missing side would just be 13. Now, to summarize what you already know, we already know so far in this unit that a quadrilateral has 4 sides and that the sum of the angles is 360. So if I add up all of these angles in this picture, all 4 of these, the total is equal to 360 degrees. We've also learned about 2 special types of quadrilaterals. We've got parallelograms, where the opposite sides are parallel, which means this guy is parallel to this guy, and this guy is parallel to this guy. And the opposite sides are also congruent. So the top is the same size as the bottom, and the left is the same size as the right. We also know that the opposite angles are congruent. So this angle is congruent to this one, and this angle is congruent to this one. And we also know that the consecutive angles add up to 180. So if you take any 2 angles that are in a row and you add them up, you're going to get 180 degrees. Parallelograms sure do have a lot going on. Lastly, we know that the diagonals bisect each other. So if we were to look at the diagonals of a parallelogram, this one would be cut in half and have 2 equal pieces, and so would this one. But not all 4 pieces would be the same size as each other. 2 different sets of equal pieces. Within the parallelogram family, we also have rectangles. A rectangle has all the same properties of a parallelogram. The opposite sides are still parallel, the opposite sides are still congruent, the opposite angles are still congruent, the consecutive angles still add up to 180, and the diagonals still bisect each other. But it's got a few extra special things going on as well. Not only are the opposite angles of a rectangle congruent, they're all going to be 90 degrees. So all 4 corners of a rectangle are 90 degrees. And the diagonals are congruent to each other, which means that when you cut them in half, you actually get 4 congruent segments. So when you look at the diagonals of a rectangle, the picture is going to look a little bit different. I'm still going to have diagonals that bisect each other, but in this case, all 4 pieces will be the same size, as opposed to 2 pieces that are the same, and then 2 pieces that are the same as each other, but not the same as the first 2. Let's add to the list. So here are some other shapes we're going to learn about. The next shape we're going to learn about is what's called a rhombus. A rhombus is another type of special parallelogram. That means that it's got all that same stuff from a parallelogram going on. It's just got a few extra things as well. A lot of people kind of describe rhombuses as being diamonds. So you may have heard them called diamonds before. In a rhombus, all 4 sides are congruent. So all 4 of the sides of a rhombus are the same size. Also, the opposite angles are congruent. So this angle is the same size as this one, and this angle is the same size as this one. Now let's talk about the diagonals. So in this next picture, I'm going to draw in the diagonals. The diagonals of a rhombus are perpendicular to each other. So if you kind of draw them, you can visually see it. So they actually form 4 right angles right here in the middle. The diagonals of a rhombus also bisect each other, but they're not necessarily the same length. So just like with a parallelogram, you're going to get 2 different sets of congruent pieces. So the diagonals of a rhombus also bisect each other, but they're not necessarily the same size. So in addition to them being perpendicular, you're going to have 2 different sets of congruent segments formed by those diagonals. Last but not least, the diagonals of a rhombus bisect the angles of the rhombus. So when you draw a diagonal and it cuts these angles, these 2 smaller angles end up being the same size, and so do these angles. So those end up being all the same, and these 4 angles end up being all the same. Now, that's going to help us find some interesting information about pieces of a rhombus that we don't know. Using the properties of a rhombus, can we answer the following questions? Well, in this figure, it's telling me that LM is 12, so I'm going to label that. And MN is x plus 6, and I know that this is a rhombus. Well, in a rhombus, all 4 sides are congruent. So I know that in this picture, 12 must equal x plus 6, which means I can just subtract 6 on both sides, and I would get 6 equals x as my answer. Now that means that PN must also be 12 because it's got to be the same size as this 12. So all of these sides have to be 12, so x has to be 6 and PN has to be 12. In this rhombus, it's telling me that LPN, so LPN, this entire angle right here is going to be 70 degrees. And then it's asking me to find LMW. LMW is this guy, just a half of that angle. Well, if we look back at what we said about the angles, we said that this angle ends up getting cut in half. So this half would be 35 and this half would be 35, because that's what I get when I do 70 divided by 2, which means that these 2 angles over here are the same size as well. So that's going to be 35 degrees. So all 4 of these angles are the same because they're both connected by that diagonal. PWN would be this angle right here. Now this angle right here is going to have to be 90 degrees because the diagonals of a rectangle are congruent to each other. Last but not least, let's look at our last problem. It says here that LW is 6, so I'm going to write that down, and PW is 8, so I'm going to write that down. I want to start by figuring out LP, which is this guy. Well, I noticed that those pieces are actually all connected by this triangle right here. And I also know that in a rhombus, this is a right angle. So going back to what we reviewed at the beginning, I can actually use Pythagorean Theorem to find LP. So I would say that 6 squared plus 8 squared equals LP squared. And you'll notice LP is by itself because that's the hypotenuse. 6 squared is 36, 8 squared is 64, which means I have 100 equals LP squared. If I square root that, I get that LP has to be 10. Now I want to find the perimeter. Well, if LP is 10, then all 4 sides of this rhombus are 10. So the perimeter would just be 10 times 4, which is 40. Lastly, I want to know ln. Now to find ln, we have to look at this entire length here. But in a rhombus, I know that this diagonal was cut in half. So if this half is 6, this other half has to be 6. So this is just going to be 6 plus 6, or 6 times 2, which is 12. The last special quadrilateral that we're going to talk about is a square. And again, we've all drawn squares before. We know properties of squares. We're just going to kind of officially write them down. A square is a special parallelogram. And this is important. It is also a rectangle and a rhombus. So that means it's got all that stuff going on plus a few extra things. In a square, the first thing we know is that all 4 sides are congruent, just like a rhombus. So all 4 of these sides are the same. We also know that all 4 angles are 90 degrees, just like a rectangle. We also know that the diagonals of a square are perpendicular to each other, just like a rhombus. So we're going to get 4 90-degree angles here. And the diagonals of a square form 4 congruent pieces, just like a rectangle. So all 4 of these pieces are the same size. Finally, we know that the diagonals of a square bisect the angles of a square. But here's the really cool thing. Because all of the angles are 90 degrees, in a square, all of these angles would have to be 45, because when you cut 90 degrees in half, you get 45 every time. So we get lots of 45-degree angles. Let's try some practice problems where we apply these properties. The following is a square. Find the measure of all the angles. So the first thing is find the measure of angle GEM. So GEM is right here. GEM has to be 90 degrees because in a square, all of the corners are 90 degrees. Next, find the measure of angle GSE. GSE is right here. GSE also has to be 90 degrees because in a square, those diagonals are perpendicular to each other. Next, find the measure of angle GAS. So GAS would be right here. In a square, all of those smaller angles formed by cutting the diagonals across the square are going to be 45 degrees because you're bisecting all of those angles. Again, we have a square. In the following square, GE is 50. So GE would be this side right here. I want to find SE, so this side right here. Well, SE is one piece of this triangle that uses the 50 degrees. And this triangle happens to be a right triangle because we've got this 90-degree angle in the middle. Now, also because this is a square, I know these 2 pieces are the same size because the diagonals bisect each other and happen to also be congruent. So if I set up Pythagorean theorem here, I have x squared plus x squared equals 50. I can combine the like terms here. So 2x squared equals 50. If I divide, I get x squared equals 25. And then when I square root, I get that x is equal to 5. Now, if I want to know AM, it's actually a little bit easier because AM would just be the same size as the other side, which is just 50. Lastly, problem number 3 says the perimeter of this of this square, GAME, is 100. Perimeter means if I go all the way around. If I do 100 divided by 4, that tells me that each of these sides is 25. Now, I want to know several different things. The first thing is AM. AM is this guy. AM is going to be 25 because it's one side of this square. I don't know why I keep writing degree symbols. I apologize. I'm just doing it out of habit, I think. I also want to know AE. Now, AE is this guy. If I look at the sides that I know, these form a right triangle. And I know that it's a right triangle because this is a 90-degree angle if this is a square. So I can find AE by doing 25 squared plus 25 squared equals AE squared. Now 25 squared is 625 plus 625 is equal to AE squared. So if I add those up, I get 1250 is equal to AE squared. And then if I take the square root, I get that the square root of 1250 is not a very nice number. As a matter of fact, if you calculate that number, which I'm going to do right now on my calculator, the square root of 1250 is equal to 35.35533, something crazy. I'm going to round that to 35.4 for AE. Now, the last thing that I want to know is I also want to know AS, and AS is right here. That's going to be half of AE. So if I just do 35.4 divided by 2, I believe that I get 17.7. Let me just double check on my calculator. Yes, 17.7. All right, that is it for today's video. Thank you guys so much for watching, and I will see you soon for some practice.